Okay, year 11. Some people have asked about, or some students have asked about equations of tangents and normals. So I'm going to do a quick video on how to find the equations of tangents and normals. Now, so I've gone to the textbook and I've found out where we've got normals, and I've got this diagram here. It's going to be able to illustrate it. Whenever you've got a curve, you can draw a tangent to it, which just means it's the tangent will be the straight line at whatever point you choose. So here we've got a point P, we call it xy, and you can see the equation of the tangent here, or the tangent's just going to be that line there. Now the normal is just the line that goes at 90 degrees to that. So you got your tangent, you've got your normal. Now finding the equation of a straight line is something you did way back in year 9 and year 10. And we're going to use y minus y1 equals m outside of x minus x1, which is a point gradient formula. Because all you need is a point, x1, y1, and a gradient. Now, the whole basis of your course is calculus. And when you differentiate any function, you need to remember what you're finding. You are finding the gradient of the tangent at that, or at any point. If you differentiate a function, you are finding the gradient of the tangent at any point. Now, if you're given a specific point, all you have to do is substitute that point in. Let's have a look at the example they give us. So here, the question here was find the equation of the tangent to the curve, this curve, a quartic, at this point. So look at what they do. They differentiate it straight away, get a mark. At the point 2, 4, well, they put 2 everywhere there's an x, and they get the gradient of the tangent. So they've got a point, 2, 4, and they got the gradient of the tangent. And then you just use this formula, y minus y1 equals m outside of x minus x1, to get the gradient, the equation of the straight line. So you put your gradient in, 3. You put your y value in and you subtract it. You put your x value in and you subtract it. You get 3x minus 6. And they've done this. I'm pretty sure they've done this incorrectly, because that's y minus 4 equals 3x minus 6. And you add that over and you get y equals 3x minus 2, which they've got down here. Geez, that's some bad working. All right, so the best way to do these is to go and look at past papers. So I downloaded some past papers, and this is the second attempt I'd had at making this video, because I went and I started doing ones which you can't do. So if I have a look, so we'll just have a look at some of these. In 2019, here's a question that they asked. It's worth 3 marks. We could do it, but it asks it in a really roundabout sort of way, and it gives you the equation of the tangent, and it tells you to find these points A and B, and I really don't want to start with that one or do that one. And then I went to 2018. There was one in 2020, but again, it was too difficult. When I looked at 2018, and I went and did it, but we haven't started doing differentiation of trig functions yet, so we can't do it. But you can have a look at what I did. I substitute. So here's a question here. Find the equation of the tangent to the curve at that point. Well, they didn't give me a y value, so the first thing I did is I put in my x value, found my y value, got a point. Then I differentiated and found my gradient. And then I just used y minus y1 equals m outside of x minus x1. But we're not going to spend some time on that. The same thing happened in 2017. It was we can do 2017. So here's a nice easy one. So here it is, and I'm going to get rid of all this and go through it. So you can see me get it from the get-go. So, beautiful, easy question. Find the equation of the tangent. Here's my curve, here's my point. Well, I've got a point, great. 1, -2. I just need to get a gradient. So what do? I write the equation, y equals x squared plus 4x minus 7. I differentiate, y dash, 2x plus 4. To find the gradient of the tangent, substitute in this x value. 2 times 1 plus 4 equals 6. So now I have a point, 1, -2, and a gradient of 6. Y minus the y value equals m outside of x minus the x value. Too easy. Y plus 2 equals 6x minus 6. Now, how you then write this is up to you. I'm just going to take that 2 over 6x minus 8. Now, you need to be able to look up past papers and to get them. So what was that? 2017, HSC 217, Maths Solutions. Marking guidelines from NASA, beauty. Look them up, here they come. What question was it? 12A. So we go along here. Come on, 12A. Oh, come on. Oh. How many more are there? 12A. And have a look. There you go. Y equals 6. It's exactly the same way. All right? So let's have a look at a few more years. 2016. Well, 2016 I don't want to do either because, again, it's a trig function which you haven't done the derivative for. But look what they give you. This time they give you a curve, they give you x. All right? And then they just say, find the gradient of the tangent. So you don't even need a y value. You just differentiate, sub in x, and you get the gradient of the tangent. Let's have a look at 2000. I don't want to go 2014. I want to go 2012. It's nice and easy, I'm pretty sure. So look at this. Find the equation of the tangent, y equals x squared, where x equals 3. So first, I've got x equals 3, but I've got no y value. So I need to find the y value. So, hold on, I'm going to sneeze now. Excuse me. So I get y equals x squared. Oh, well, 3 squared is 9. So I've now got my point, 3, 9. I just need the gradient of the tangent. Well, if y equals x squared, dy dx equals 2x at x equals 3. So the gradient of the tangent at x equals 3 is 2 times 3. Oh, that's 6. So now I have a point and I have a gradient. Y minus the y value, 9, equals the gradient, 6, x minus the x value, which is 3. Y minus 9 equals 6x minus 18. Let's take this 9 over. Y equals 6x minus 9. Go and look it up. So we'll go back. What was that? HSC Solutions, what year again? 2012. Sample answers from the Board of Studies, you beauty. What question was it? 11C. There we go. All right. They've done it a bit of a weird way there. I want to just differentiate and substitute in. I don't know what they're doing. Anyway, so 6x minus 9. Is that what we got? 6x minus 9. Right. Now, it took me a while to go back and to find a normal. I had to go all the way back to 2000. Was it 2003? Yeah, 2003, because I've already done it. And it's a hard one. So I'm just going to get rid of all this because I'm going to do it again. And I'll get rid of that. So 2003, here's the question. Find the equation of the normal to the curve y equals 2 log e x at the point E2. So give me a curve, they've given me a gradient. Now, I know that we haven't done differentiating logs, but I'm going to do this question nonetheless. So here is the equation of y equals 2 log e to the x, and that's 1, because the log of 1 is 0, and 2 times 0 is 0. And then we've got 2 and 3. Now remember, E is, well, what is E? What's the value of E? Well, it's, 2.71 something, 2.718. So E is about there. And that's going to be the point E and 2. Now, normally, we'd be finding the equation of the tangent. But we need the equation of the normal, that green line. Knowing that helps you understand what sort of equation you're going to get. So this is my so what do? First thing, I'm going to differentiate this. Now I know you don't know how to differentiate this, but trust me, that's what it is. The derivative of log x is the derivative of the function over the function itself, so it becomes 2 over x. We're going to learn that next year, or next term actually. So now at E and 2, well, what's the gradient of the tangent? I just put E into that equation, 2 over E. But I don't want the gradient of the tangent. I need the gradient of the normal. Now here's where you've got to be smart. The normal, if two lines are perpendicular, m1 times m2 equals -1 if two lines are perpendicular. And that's what these are. So m2, the gradient of the normal, is the negative reciprocal. So all I do is I turn this thing upside down and change the sign. So it's negative e over 2. All right. And now I've got a point and I've got a gradient. So I'll just go y minus the y value equals negative e on 2, that's the gradient, x minus the x value. And this is where you've got to be smart. You take this 2 and multiply it by these two things here, and this negative e and multiply it by these two things here. So you get 2y minus 4 equals negative e x plus E squared. Now you've got a choice here. You can write the equation any way you want. I'm going to bring all these things over to the left-hand side of the equal sign, change the sign. So I'm going to get EX. I've already got the 2y there. I've already got minus 4. I'm going to have minus E squared, and I'm going to have it equal to 0 because that is the general form of the equation. And that's it. That's the equation of the normal. If we check it out, and we go, let's go back and change that to 2003. Notes from the marking centre. What question was it? 2A. And here it is. Now, they don't give you the solution here. They put something else in here, but they write about what happened. And those candidates who correctly differentiated the function generally went well. Common errors, treating 2 ln x as linear, having the gradient. Others simply found the equation of the tangent, did not find the normal. Okay, so making sure you do that. So let's look at one more. So we can go to any year. So have we gone 2012? Right. So, oh no, we've done 2012. I skipped 2014. I might have a look at, let's go to 2004. What was it like in 2004? Who knows? I haven't looked at this one yet. It may not have one. They usually do. Radius differentiates, so I'll find the impact, find that. What is the size of the angle? Differentiate. I don't think they have one this year. Consider the function. If you haven't found it by about now, it really probably won't be in there. So what was that? 2004, 2003. Let's go 2002. There you go. Look at that. Perfect one to finish on. So find the equation of the tangent to that at that point. So we've got a point, 0, 1. We've got this equation y equals e to the 2x. We differentiate y dash, same thing, multiplied by the derivative of the exponent. There's a gradient of the tangent. It's a gradient function. Therefore, the gradient of the tangent is 2e to the 2 times, put in the x value, 0. 2e to the 0. Anything to the power of 0 is 1. 2 times 1, 2. Okay. I'm going to use y minus y1 equals m outside of x minus x1. I've got my gradient. Here it is. And I've got my point, 0, 1. So what do? Y minus the y value, 1, equals 2. X minus the x value, 0. Y minus 1 equals 2x. Take that 1 over the other side. Y equals 2x plus 1. Check. So when was that? What year are we looking at? 2002, I thought. Yep, 2002, question 2A. So you go back, have a look. We want 2002. By the way, you can do all this on your own. Notes from marking centre. Here we go. We want question 2A. Went too far. Common errors. It was disappointing to see. Am I trying to? Okay. They're just the common errors. Differentiating wrong. Hmm. All right. So that's gradients of tangents and normal, or equations of tangents and normals to curves.